Hello. Our project is development of an intelligent IPS, IDS, and IRS system using machine learning on an IoT infrastructure for precision agriculture. Our DPI is the engineer Nestor Javier Arriaga, and uh, my name is Gabriel Villanueva, and my partner is Tomás Guijo. So this project has already been partially implemented in eh, los laboratorios de sistemas telemáticos en Escuela Politécnica Litoral. This project already has an IoT infrastructure that has an IDS system that can detect whether there is an attack on the IoT network. However, there are some things that need to be improved. The first one is the dataset. So the system has an anomaly module that detects whether the data that is collected by the node sensors um, have any irregularity. And that data set was collected in the last year. And one of the problems is that this data needs to be updated. The second problem is that the IoT network is implemented using a Wi-Fi protocol, which is not which doesn't allow for a large range between the nodes concerning the distance. And finally, like I said before, the system already has an IDS system that is able to detect whether there is a malicious attack on the network, but it doesn't do anything about it. It just notifies the user that there is an ongoing attack. So for this project, we have detected these objectives. The first one is to implement a module capable of taking actions when there is an attack detected on the network. Second is to improve the wireless network that exists in the IoT infrastructure. This will be using a protocol other than Wi-Fi. And finally, it is to automate the upgrading process of the dataset used by the machine learning in the anomaly module. For this, the materials that we have identified to implement this project are the microcontrollers. In this case, the base node of the IoT infrastructure is the Raspberry Pi module 4. And for the sensor nodes is the ESP32. We will also be using Skylearn, that is a Python library that allows us to use machine learning. For the automation of the upgrading of the dataset, we'll be using shell scripting in order to configure a cron tab. And finally, we'll be using Zigbee modules to replace the Wi-Fi protocol that is already been implemented. For the implementation, we have the next points. The first of all, it will be to use IP tables for the IPS and IRS systems. The use of IP tables will allow us to filter the traffic that is being detected that is malicious, that is detected as an attack on the network. Second, it's to verify that the network ports that that it's to verify that the network ports that don't need to be open remain closed. And the third is the configuration of a cron tab that is an OS job. And this job will be executing Python scripts in a span of 7 days to upgrade the data that is collected in the dataset to train the anomaly model. And finally, we'll be using Zigbee modules instead of Wi-Fi in the wireless network, so to improve the distance that can be allowed between the nodes in the IoT infrastructure. Here in the slide, we can see the IRS and the IPS system at work. First of all, detecting by sniffing the packet in the packet in the traffic network. In this way, we'll be able to detect whether there is an attack ongoing on the network, and finally implementing an IP table rule in order to block that that traffic.
After the test we did, the analysis of results and restriction, we conclude that IPS mitigate attacks, but it doesn't stop them. The dataset script does not validate the collect data, and CB communication is capable of covering more ground for this project. The conclusion, machine learning can help us to predict attacks. Do the traffic collect data? Is the possible to create rules to filter dangerous traffic? And it was concluded that using the proposed systems is possible to mitigate attacks on the IoT device. The recommendation is, it is recommended that when we are making any modification to the network in which the sensor or microcontroller are connected, you also make that change to the proposed code. Statistically, place the IP statically place the IP address of the equipment to avoid any type of loss at the time information for the transmission. For future years, we recommend applying this system in conjunction with LoRaWAN to amplify the coverage of the equipment at the graded distance, and in additional generate an intrusion detection evaluation dataset to verify and analyze the users that enter into the network. Thank you very much, and that is the project that we present here today.